This is Britt Caswell with another example video. In today's video, I'm covering example 1 from lesson 6-6 in the SavvasRealize Algebra 2 textbook. The goal of today's video is to solve exponential equations using a common base. So here in example 1, what I'm actually trying to do is trying to avoid logarithms. Alright, so this is how I taught how to solve these problems before we had any logarithms in our kind of toolkit. So depending on what the numbers are that have exponents here, what we could do is we can rewrite these expressions. So 1/2 can be written as 2 to some power, and 4 can be written as 2 to some power. And by changing how those are written, what that does is that enables us to compare these exponents. Alright, now 1/2 is 2 to the negative first power, and 4 is 2 squared. So before I can get rid of the 2's to compare the exponents, I need to actually write the exponents as a single exponent. So I'm going to be using my power of a power rule to kind of distribute the -1 and distribute the 2. Alright, so I have 2 to the negative x minus 7, and here I have 2 to the 6x. So really what I'm going to be doing on each side here is taking log base 2 to remove the 2's, but I could just set the exponents equal to each other. And now it's all about solving for x. So here I'm going to add x to each side. So I get that -7 is equal to 7x. And I'm going to divide by 7 and run out of room because I planned poorly. So when I divide by 7, I get that -1 is equal to x. Alright, now let's go ahead and let's try it here in the try it. So 25 and 125, those are both 5 to some power. So 25 is 5 squared, and 125 is 5 cubed. And so I'm replacing those inside of the equation. Now I'm going to distribute those exponents. So this turns into 5 to the 6x equals 5 to the 3x plus 6. And because those bases are the same, I could set the exponents equal to each other. And now I'm just solving for x. So I'm going to subtract 3x from each side, which says that 3x is equal to 6. Then I divide by 3, and I get that x is equal to 2. Alright, one more time just for funsies. So these ones are 10 to some power. That one's just 10. I don't have to rewrite that one, I guess. But that 0.001, that is 10 to the negative 1, 2, 3, 4th power. Where's that the negative third? Let's see. So 10 is to the first power, right? 1 is to the 0. 0.1. That's just a 1, by the way. 0.1 is to the negative first. 0.01 to the negative second. 0.001 to the negative third. I was right the first time I thought about it. So see, sometimes you might need to write out those exponents to remind yourself, what they are, and that's okay. Right? Even somebody who's advanced at math sometimes has to rethink it. So now that I have two expressions with 10 as my base, I'm going to go ahead and set them equal to each other. And then my last thing is to solve for x, so I'm going to go ahead and divide by 6 on each side. So -3/6 is -1/2, which is my x value. So there we have it, guys. That's how to solve exponential equations using a common base. Until next time.